I will start this practical session. And before I start the practical session, I have one announcement. We will have project on next Thursday, so remember this. Okay. I'm Yeon-soo Hwan, the TA in charge of this practical session. And the practical session is about convolution neural network, CNN. Okay, before I start the lecture, you have to change the type of runtime. You have to change GPU, not CPU. Okay, please change your runtime. Okay. First, import all the requirements, libraries and data set we will use in this lecture. In this session, we build simple CNN to classify MNIST and implement ResNet for CIFAR10. And download MNIST dataset. We built dataset into train, valid, and test. Okay. We also download CIFAR10 dataset in here. For CIFAR10 dataset, we use conventional transform and normalization like this. Maybe someone may have questioned why we use transform like this. It's just a hyperparameter, so you can change whatever you want. I choose this hyperparameter because this turned out to be good to CNN. So we use this one. So download CIFAR10 dataset too. Okay, now let's define our convolution layer and practice this session. If there is a tensor of shape 1 by 3 by 32 by 32, what is the meaning of each dimension? First dimension means the batch size, and second one is channel like RGB, and third and fourth is width and height. In this practical session, this shape means this 32 by 32 with 3 filter image, and we'll make this tensor. And let's define our convolution network. How do we define convolution network? So just like you did torch.nn.linear later, there is comp2d. In the conventional arguments of comp2d, there is 5 arguments: in channel, out channels, corner size, padding, and stride. In the example of this image, the in channel is 3, and the out channel would be 1. And the corner size is this one, so it will be 5. And padding, in this example, the padding would be 0. If we do not define the padding argument, it actually gonna be 0. So it is okay to do not write padding argument if you want to define padding as 0. but now I give padding like this. And the stride, let's calculate the stride. But do you know how to calculate the output width? The output width is like original width minus filter width plus 2 by padding and divided by stride plus 1, right? So in this case, the output is 28 here, and the original width is 32, and filter is 5, and padding is 0. So and stride divided by stride plus 1. So in this case, the stride would be 1, right? So this the convolution layer we define. And let's check out the output size of the convolution layer. Yeah, it is 1 by 1 by 28 by 28 after the convolution layer. And okay, quiz time. This is the input volume is 32 by 32 with 3 channel, and then we want to convolve with 10 5 by 5 filter with stride 1 and pad 2. I will give you 3 minutes and do it. After 3 minutes, let's check together. GPU setting is I use you can use T4 GPU, T4 GPU, T4 GPU 사용하시면 됩니다. Okay. Let's do it together. The batch size is like one and channel 3. All right. Guys, and it is the same like this one. Okay, so the input channel is 3 and output channel would be 10 and corner size would be 5 and stride 1 and padding is 2. So I will see the output. It is 1 by 10 by 32 by 32. Everybody follow up this. Okay. Good. And okay, let's do batch norm and dropout layer. You guys learned batch norm and dropout layer last time. And if there is tensor like 1 by 3 by 32 by 32, we define the batch norm 2D because it's 2D data set. And we have to define the number of feature here. This is same with the output channel size. So it'll be 3. Remember that if we do batch norm, it does not change the input size, right? And if we do different number with the channel, what's going on? We face with the error. So number feature must same with our channel, and let's do dropout. We define 2D dropout. This is the probability how much we turn off the neuron. In this session, I just defined the probability 0.5, but you can change whatever you want. And after dropout, the size of the input does not change. Okay. So let's build the simple convolution neural network. This is the module class for the convolution neural network. We define NN sequential with convolution, batch norm, and ReLU, and then again convolution, batch norm, ReLU, and lastly we use fully connected layer. So I will give you 5 minutes to fill the blank and check out together. The asset, this image, you cannot load this image. It's just for the lecture. 이 이미지는 로드할 수가 없어서 저도 지금 로드가 안 되는 상황이어서 이건 그냥 이 렉처를 위해 넣어놓은 이미지라고 생각하시면 됩니다.
I think that today's like TA session.
Okay, I will share the image after this practical session. But you can see this image in the last session's professor's lecture PDF. Okay. Let's check together. We use CNN to classify MNIST dataset. So MNIST dataset size of X would be batch size is on grade A 28 and one this is and okay and 28 by 28 because MNIST is 28 by 28 and output is batch size and 10 because MNIST is 0 to 9 and first we have input and output, batch norm, and ReLU. And first X shape should be 8 and 1, 8, 28. And so what is this? In comp layer, we use this one. And the input channel is 1 and output channel is here 32 and corner size is 7 and we do not have we did not need padding, and stride is 1 and batch norm is same as output channel, so it'll be 32 and okay. And after this layer 1, we face with X output is 100. And what is the output size? How we calculate it? This is 28 minus 7 plus 1 and 22 by 22, right? So after this output come into layer 2, and the comp layer is input channel is 32 and output channel, out channel is 64 and corner size 1 and stride 1, and this is same as out channel, so it is 64. And after this out layer 2, what is the size of our output? And 22 minus 7 plus 1 is 16, right? So after this, we flatten the output. The 1 means flatten one dimension, flatten the dimension with 1 dimensions. So the final output would be like and 10. So in linear layer, we use flatten this like this and like this. Everyone follow this? Okay. This network to CUDA. Okay, and okay. We flatten this output to 1 dimension. So this gonna be flatten the shape of out. And what if we add padding 3 in comp2D layer? If we add padding 3 in comp2D layer, we have to change the linear size of linear because first okay. I will explain this first. If we flatten to this output dimension to 1 dimension, it's gonna be like this, and we flatten like this 10 like this to make output shape like this, because the MNIST data set is consists with 0 to 9 number of image. So this is what is flattened. What if we add padding 3 and come to the layer and it makes this change the output like this. So if you print like this, and you can see what is going on with when you add the padding 3 in the layer 3. So please check out after this class session. Okay, we define the criterion that we will use cross-central pillows, and let's train it. Okay. Since the this is the eval code. Since the output is batch size by 10, so we argmax dimension 1 and see how many correct it is. The score is 99.11, and it means that simple CNN is good for MNIST, because I think MNIST is actually easy data sets. And let's do CNN architecture with residual block. Actually, ResNet is it's the same as the convolution network we defined before, like this, but it has one more argument, which is residual path. Okay. For ResNet, we typically design the block and concatenate block like this. This block is residual block, and ResNet 18, this means we concat the 3 this is classnet. Okay. Okay, I will move to the ResNet. Okay, this means concat 3 residual block, and this means concat 5 ResNet block. Okay. This is the residual block code. We give input channel and output channel, and yeah, stride 1, we downsample false, and okay. Stride is stride. We do give stride like this. And what is the corner size? Let's calculate it. Output that is original with minus size plus 2 plus right? No. Because this is stride 1 and heading like this, heading 1. And this is 3, right? So we have to make the output width and the original width gonna be same. How to make it? We make the corner size minus corner size plus 3 to 0, right? So the corner size would be 3. Okay, and after convolution network, we do batch norm and value and another convolution layer like this one. 3. Let's try this, right? And padding 1, and batch norm, and we choose downsample or not. Downsample mean max pull or min pull. In this case, we do max pull. And about how to pad, please see the detail in the document. And after, okay, so this is the how residual block works. First, we store another X to the shortcut because we have to add the end of the residual block, and we convolve X and batch norm and value and more convolution and batch norm, and we add shortcut in the last. And if you want to do the downsampling, we have to add code like this. Example. Right? Okay. Okay, this is the residual block code. Oh. And then this is ResNet. As see here, we add 3 ResNet, and the block is the residual block that we defined before. Okay, let's see the detail of ResNet. For ResNet, we will use C410 dataset. So the input channel would be 3 because this is C4 dataset. The output channel is 16. We want 16 here. And the corner size should be 3. And normally we just write like 1 And the batch norm is same as the size of output channel, so it's gonna be 16. Okay. After first convolution layer and batch norm and ReLU, it's go to get layer here. Get layer function is this for max plane. Normally when stride is 2, we do downsample. If not, we do not use downsample. Okay, and we will add the modulus in here. This is what we define in here. This modulus, and it's like oh, okay. I will see your this is residual block. Okay. And how many time we do it for? We have to number of layer time. So for and range and -1. And we append in the layer list. Like this. So in the module list, no, so yeah. Okay. For example, we define the 5 number of layer. We first do the block with the downsampling, and then with the rest of it with the residual connection, and it will the result is output and the input will be the same. And now I define the function of get layer. Let's fill this one. The feature map is 16 by 32 by 32. It would be like 16 output, and we want output like this. And try this 1, right? And how about this? This is 이렇게 돼야 되는데 out channels 들어와서 out channels 나오게 됩니다. 계속 first we do the layer list. We do like this, and yeah. And then the next layer 4, Yeah, feature map gonna be like 16 and stride is 2, right? How about this one? The feature map is 64 8x8, and yeah, 32 and 64, right? And straight is 2. Okay. We do the average pulling. This is 8x8, so it's gonna 8 here, and 8x8, so we do like this, right? And so in the ResNet class, first we do convolution layer and fetch norm, ReLU, and okay, and we do like layer 2, 4, 6, and we do average pulling in here. So max pull is done in this one in residual block, and in ResNet we do average pulling because people make ResNet do like this, so we do code like this. Okay, and let's practice ResNet 32 to train cipher 10. And we have to compare the residual connection with simple CNN. So in ResNet, we do this block with residual block we defined before, but for compare with CNN and residual block, ResNet, we do block like this, the simple CNN code. Okay. So let's train it. This is the train code. Why this? Wait. Stop. Shortcut. Wait. 3. Let's try padding 1. That is false. Right. 1. Channels downsample. Okay. Yeah. Okay, let's train this one. I don't know how long it takes. Okay. Okay, okay. I will show ResNet class again. Okay, ResNet class. This is ResNet class. Okay. This is ResNet class. Can you explain what we do with downsampling in residual block? We do downsampling to make a same shape with the input and output. So we do downsampling on residual block. Can you copy or show residual block code? Okay, I will show you residual block code here. This is residual block code. This is implement using downsampling method. Okay. While training, I will explain the code here. This is code for plotting, plot, and you can use this code to see the loss of loose, and you can see how the correct of this ResNet model. It is the same with the code that I use here. And to compare CNN with the ResNet, you have to train one more time and compare with ResNet and CNN with this, and see how residual block is good for goods. Okay, and so let's wait for training. I don't know how it takes long. Okay, ResNet here. This is layer. This is input is the output here is 16, so we put in 16, and in get layer, this is what we define in the residual block here. So this residual block is in channel, out channel, and stride and downsample. And stride is 1. And output channel is we want to make the feature code to like this. So the output gonna be 16 here. And after this layer, we add the input channel will be the 16, and we want to make a feature map 32 by 16 by 16. So the output size would be 32 and stride would be 2 to make this one, to make the feature map size like this. And after this layer, the input size is gonna be 32, and we want to make the feature map size 64 by 8 by 8, and the output size will be 64 and stride will be 2. Is it clear? I don't know exactly about the project 1, so next Thursday we will announce project 1, so you will know what is the project 1. Yes, right? 한 번 더 공지를 하자면 다음 주 프로젝트 관련해서 다음 주 목요일에 공지가 있을 것 같아서요. 그때 들어오셔서 확인하시면 되실 것 같아요. 그렇습니다. We have class on Tuesday and Thursday. Layers. Could you show me get layers parts in ResNet? Okay. This is, you can see here. 어, 아, I will check again in, 저 화요일, 목요일 수업이 있는지 한번 확인하고 그 클래스룸에 공지하도록 하겠습니다. I will announcement classroom whether next Tuesday or Thursday have class or not. 아, 그럼 수업이 없을 것 같네요. If you want to know about whether Tuesday have class or not, you have to check on classroom. And next Thursday the project will be held, so please remember it. Yeah, it is possible to share a recording of meeting of project 1 OT. Time matter. Can you see here? Like, can you change like this one? I made a mistake in here. Let's try this, gonna be 1 in here. So if you change the code like this, I think you did not face with those error. Yeah, right. First one is like this one. Where is first convolution one is right equals right, right. You get this error from Is it all same? Check one more time, please. You implement the downsampling method like this. Okay. Good. Okay, here's try this. First, we define initialize stride in here. So first convolution layer have to stride equal stride, and second convolution layer, we have to give stride like this. Yeah, right. For the first layer in here, you have to do like stride equal stride in here. Could you show me ResNet class again? Okay, I will show you ResNet class again. This is the ResNet class. And you have to implement get layer function in here. Okay. Let's see the performance. This is the loss of training the ResNet, and you can see how ResNet correct the answer like from this code. The score is 91.447. And to compare with training the model with CNN, 어디 쪽에서 which code do you error face with the error? Before you run this code, you change to GPU runtime type to GPU and runtime to GPU. Please check it one more time. And if you want to because of time, we don't have much time, so we do not have enough time to train the CNN for comparing with ResNet. So after class, we will upload the solution file and CNN code in the classroom. Please run this training code and see the performance between CNN and the ResNet. We will end up the class. 수업은 여기까지 하겠습니다. 시간 관계상 이쪽 뒤에 트레이닝 하는 거는 해보시는 게 좋을 것 같습니다. 감사합니다.